Now we are welcoming Miroslav for building on-chain infrastructure for real-time multi-user control. Thank you for being here, and please continue with your talk. Thank you.
Thank you very much for being here. So I'm going to talk about the open infrastructure for real-time multi-user control. Something about me, who am I? Professionally, I'm working with video streaming engineering, and I do it apparently also in my free time. I'm an open source developer, and I'm gonna show my open source project now for you. So what is Neko? Neko is basically a self-hosted virtual browser, and it runs remotely. You can think about it as having a virtual browser on computer, and multiple people connect to it and watch the same content at the same time. Everything is working through WebRTC. That means you don't need any client software to access it, and it has a really low latency. It's about multiple users joining the same session, so you can watch together, synchronize the same content with multiple people. There is a shared video and audio, and the interaction is also shared. And I'm going to talk about how the interaction part is managed for this project. Maybe you're asking yourself, why does this even exist and what is it? There used to be a service called Rabbit 5 years ago, but it completely disappeared. People used to watch movies together, browse internet together remotely. And since it disappeared, there was no any alternative. But people still wanted to do this thing. People still wanted shared browsing, and people still wanted the shared interaction. The problem never went away, and there was no solution for this. So let's take a look at existing solutions, what might be there. You might think of screen sharing like Zoom or Meet or Teams. Those solutions don't solve the problem that we currently have because they are only there passively. So multiple people can watch. There is only one presenter. There is no interaction. There is also no isolated environment. So everything that you are sharing is your screen. You can share your tab or window. You also need the bandwidth to stream it to the internet, which requires another upload. It's a simple setup. You don't need anything. It's widely available, but it's not solving the collaboration. Another use case could be remote desktop. There exist multiple protocols like VNC, RDP. We have TeamViewer or AnyDesk. There is also no VNC or Apache Guacamole available on the web without installing any client software. They give users the full desktop access. It works with any application, but again, it's only meant for one user controlling, and there is no support for multiple interactions. There cannot multiple people cannot connect there, and if it would also allow it, there would be a chaos if everybody wanted to control at the same time. Another solution could be collaborative editors like Google Docs or Figma. They offer native collaboration. They are really efficient on synchronization. They are built for massive editing, but they are application specific. So there is no real-time media. You can only edit the document that is available. There is no possibility to plug in any other application that has been built specifically for this kind of collaborative editor. So there is no support for arbitrary context. The last solution could be cloud browser platforms. There exist some online, like Hyperbeam or BrowserStack. They allow isolated environment, browser as a service online. They offer remote workspaces, but they are managed infrastructure. Who owns the cookies of the browsers? Who owns the interaction? It's everything on cloud. It's not something that we can self-host. So that's their biggest problem. This is exactly where Neko is positioned and fills in the gap. Where we want many viewers, we need a shared interaction, also a real-time media that is self-hosted and offers explicit ownership. There is nothing that would be available. That's why Neko was created. So what is Neko again? It's a browser that runs in browser. It can be accessed through WebRTC, and now we established that it allows multiple users to control at the same time. But there is catch. How can we create this without the chaos? Because if we have multiple people controlling at the same time, it's a problem that needs to be solved. And none of the previous solutions solve that for any application that is available. People use it also for not only for the interaction. There is like this watch party, so people watch videos together on Neko. They can do interactive presentations where people can actually join the presentation and play themselves with the application that is being shared. It's used as a collaborative tool. It can also support by teaching. So if somebody is teaching through Neko, it can give the control to the other users and they can try it by themselves. It can also be used for embedding anything on the web page. So if somebody wants to embed their application that is vendor specific, it's not available for web, it can be streamed using WebRTC to the web page, and the logic stays at the server and is never exposed to the client. So it's also protection for the theft. And it also can be used as automated browsers for AI tools that can as well interact with it the same way as people are interacting with it, and it allows possibility to always have user to join the session and do some tasks manually if it's not done well by the AI, so intervene. We still have the real problem even after all these use cases. So let's say we have 20 people that want to use this tool. Everyone wants to click, everyone wants to interact with it. What are we going to do? We have only one browser. Even though we have many users, there is still only one state. We cannot have multiple cursors. We cannot have multiple actions happening at the same time. If somebody clicks on different things at the same time, who is going to win? Which click is going to be then used? There can be a lot of conflicting actions, and the collaboration would be then just pure chaos. The wrong solution would be, of course, to accept all of these clicks, to basically merge all actions and allow everyone to just click on the web page. We hope to resolve conflicts by accessing who was the first one to click and just hope for the best. But then we don't know who is actually controlling it. We don't know what's happening. The collaboration becomes just a noise. So that's where Neko comes in and introduces its ownership model. Neko has one active controller that defines an explicit ownership, and it uses transferable control, thus creating deterministic behavior. It means there are many users. There is one host token that can be passed between the users, and who has this one token can actually control the browser. So we don't merge the intent, we serialize it. The architecture of Neko is as following. We use the capture layer to get the actual stream from the desktop sharing. Then we distribute it to multiple people using WebRTC. Then we use the arbitration to decide who gets to control. And after we have the specific user that is controlling the host, then the one gets the execution on top of the layer and gets to control the browser. So let's look at the architecture. The capture distribution, it basically captures the desktop output. So we run the browser in X11 environment with pulse audio that is just grabbing the screen. GStreamer is used as a frame buffer capture to get all the data from the screen. The WebRTC then is distributing this to all the users. We encode the media in H.264 or a VP8 format because they are available on the browsers, and users don't need to install anything and can just open a web page and browse our browser. The WebRTC was used because it's low latency with video and audio. I will get to that later. so that everybody sees the same thing at the same time. But we could do it also using HLS or FMP4 over WebSocket. But why did we choose WebRTC? The WebRTC is a standard in current browsers for video, for ultra low latency video and audio. All the solutions before also mentioned, they might lack the audio support, but the WebRTC gives us this ability to have also audio support, and it supports adaptive streaming. So we can decide, we have 20 users connected, and they have different bandwidth constraints, and we can decide which one gets what kind of video that we encode on the server. WebRTC was built for the real-time interaction, so it's a perfect fit for this project. The next level is arbitration, which is the most interesting part. It defines who is the host ownership, and it defines the whole permission model. In this layer, the control is being transferred from one user to another. There are multiple users, and they can request who is going to get who is going to control, and server decides who gets the control based on their levels of administrator levels, or if there is a possibility to who is going to basically control. The control flow is as follows. So the user can request control, WebRTC, data channel, and server can validate if they get to control or not. So if there is already a current user hosting, they need to get approval, and the host needs to give up their ownership, and the other person can then take the ownership. If there is no other user and the current user is allowed to control, the control is granted immediately and the user can grab the control. But on approval, there will be a pop-up for the administrator that is currently hosting the session, and we want to allow this user to own currently the ownership. They get to have it, but since they are not the administrator can take the control at any time they want. All viewers are notified of this change. That means everyone knows who is the host at every time. There is a log of events, and it's absolutely it's audited who gets the control at which time, so we can trace in the back when there is some actions done on the server that were not intended. There is a full log of who had control at which time. The last layer is execution. It's currently X11 server that is using the XTest, which is a specific library for the Xorg server that allows faking user input. There is also another custom driver for touch inputs, so users with touch screens can as well access this, their events. Pulse audio is used for virtual microphones and speakers, and V4L2 loopback is for webcam pass-through, so we can actually connect the user's microphone and webcam, and the users can have the native experience as if they would have their browsers locally. But the interesting part is that this execution layer is independent and is actually just an interface that can be implemented by anything. So this leaves us with possibilities in the future to control anything, as the system doesn't know that it's controlling a browser or another application or anything that is underlying it. That means it must not be only browsers what's supported. There can be full applications, it can be full desktops, some virtual machines, even like robotics, or I can also imagine drones that can be just controlled, and like PTZ cameras. There is literally no limitation if we set up the architecture correctly. This is an example of what already is implemented. Most of the applications are already coming from the open source users by themselves, what they saw that they want to use it for, and already implemented nice applications for Neko that fulfills their needs. Um, that's actually the main takeaway that I want to give you from this talk is that this open source project is there so that you can own the infrastructure, not only the infrastructure and code, but also own the interaction, which was not yet addressed in many of the open source projects that I looked through. With replacing the execution targets, it can be forked and used for literally anything that the imaginations allows, and the architecture is reusable. Even though currently there is only a browser and applications, the architecture allows for anything in the future. Fork the browser, fork the desktop, fork the future. This fits the conference theme. So wrapping up, shared control is really hard. We went through existing tools that do not solve the problem. I've shown how Neko is solving this problem explicitly, and the architecture that was created just because we wanted to watch videos together 5 years ago now extends beyond browser and allows for shared interaction that was not dreamed of before when creating this project. Thank you very much.
Very interesting session. I wanted to explore more. As you said, it's more than a browser. So,
yes.
Yeah. And any questions in the room? If not, we can also continue after. You can ask also questions after the talk. Okay. Thank you so much again, and thanks for giving such a talk. Thank you.
Thank you.